Hello, today we are doing section 2.2, Mathematics and Science. Here's our riddle for you. What do the following things have in common? Microscopes, telescopes, thermometers, balances, and mathematics. Do you give up? The answer is that they are all tools the scientists use. Does it surprise you that mathematics is included in this list? You probably think of mathematics as something that is separate from science, but it is not. In fact, mathematics is sometimes called the language of science. Mathematics is essential for asking and answering questions about the natural world. From making measurements to collecting and analyzing data, scientists use math every day. This section focuses on some of the important math skills you will use in science class. Estimation. Have you ever been on stage and wondered how many people there were in the audience? Maybe you counted the number of people in one row and multiplied by the number of rows. This would be one way to arrive at an estimate. An estimate is an approximation of a number based on reasonable assumptions. Estimating is not the same as guessing because an estimate is based on known information. Okay? So here in this example, there are 36 birds in the highlighted or one of these squares. The total area is 6 times larger. Thus, you can estimate that there are 36 times 6 or 216 birds in total. This is how estimating is different than guessing. Scientists must sometimes rely on estimates when they cannot obtain exact numbers. Astronomers, for example, can't actually measure the distance between stars. Park rangers can't count the number of trees in large forests. Instead, scientists find ways to make reasonable estimates. An astronomer's estimate might be based on indirect measurements, calculations, and models. A park ranger's estimate might be based on a sample. The ranger could count the trees in a small area and then multiply to estimate the number in the entire forest. Okay? So look at the math skills here. Area equals length times width. We've done this many times in math class. Part of your homework will be problem 1 and 2 here. Accuracy and precision. Suppose you were to meet a friend at 4 p.m. Your friend arrives at 4:15 and says, but it's 4 o'clock according to the clock in my house. The problem is that your friend's clocks do not show the accurate or correct time. Accuracy refers to how close a measurement is to the true or accepted value. An accurate clock would read 4 p.m. However, if all of your friends' clocks are about 15 minutes late, then they can be said to be precise. Precision refers to how close a group of measurements are to each other. So if you look in the above picture here, you can tell that the target, if you're close to this target, it would be accurate. So these are not accurate. They're also not precise because they're not close to each other. In the bottom picture here, you can see that they are precise because they're close to each other, but they're not accurate because they're not close to the target. And this one here, in this very, very bottom, you can see that they're close to the bullseye, which means they're accurate, and they're all close to the bullseye. So they are both precise and accurate. Accuracy versus precision. As you can see from the clock example, accuracy and precision do not mean the same thing. To understand the differences, think about a game of darts. As figure 11 shows, accurate throws land close to the bullseye. Precision throws, on the other hand, land close to one another. Accuracy and precision in measurements. Both accuracy and precision are important when you make measurements. For example, suppose your younger sister wants to find out how tall she has grown. When you measure her height, the measurement needs to be accurate or close to her true height. The measurement also needs to be precise. This means that if you measure her height several times, you can get the same measurement again and again. How can you be sure that a measurement you make is both accurate and precise? First, you need to use high-quality measurement tools. Next, you need to make your measurement carefully. Finally, you need to repeat the measurement a few times. If you follow these steps and get the same measurement each time, then you can feel confident that your measurement is reliable. Significant figures. We've also done significant figures in math class. Whenever you measure something, you are giving meaning or significance to each digit in the measurement. In fact, scientists use the term significant figures to refer to the digits in a measurement. The significant figures in a measurement include all the digits that have been measured exactly plus one digit whose value has been an estimate. For example, you might estimate that the tile in figure 12 is 5.3 centimeters. So, see how you know it's past 5, but you don't really know that's 0.3. It could be 0.4. You don't know. You're estimating that it's 0.3. But you estimate 3 on the other. To find the number of significant figures in a measurement, count the number of digits that were accurate. So in this case, 5 was accurate, plus one estimated digit. Therefore, the measurement is 5.3 and has 2 significant digits. Do you see how the 3 is an estimate? Adding and subtracting measurements. When you add or subtract measurements, the answer can only have as many figures after the decimal point as the measurement with the fewest figures after the decimal. For example, suppose you add a tile that is 5.3 centimeters long to a row of tiles that is 21.94 centimeters long. Notice the 4 in this one is the estimate, and you really know that it's 21.9. So when you add these two together, you get 27.24. But we have to take this 3 in the tenth place as the estimate value. So we would report this answer as 27.2 centimeters and has only one significant figure after the decimal because the measurement 5.3 centimeters has only one figure after the decimal point. Why is it incorrect to express your answer as 27.24 centimeters? The reason is that your answer would appear to be more accurate than it really is. Remember that when you first measured the tile, you estimated the 3 in the 10th place. When you add the number to another, the number in the 10th place is the sum, is still only an estimate because you estimated the 3. If you express your answer as 27 and 2400 centimeters, the 2 in the 10th place would appear to be the exact measurement rather than an estimate. Multiplying and dividing measurements. You need to follow a slightly different rule when you multiply or divide measurements. When you multiply or divide, the answer can only have the same number of significant figures as the measurement with the fewest significant figures. Suppose you need a tile space that measures 2 and 2500 meters by 3 meters. The area of the space would be calculated as follows. So in 2 and 2500 meters, you have 3 significant figures. In 3 meters, you only have one significant figure. So in this case, when you multiply this together, you get 6 and 7500 meters squared. But because the 3 only has one significant digit, your answer would be 7 meters square. And the answer has one significant figure because the least precise measurement, which is 3 meters, has only one significant figure. Okay, you'll have to do some of these in your homework. Percent error. Today, class, your job is to determine the density of this metal. With those words, your science teacher hands you a small piece of shiny metal. You get to work carefully measuring its mass and volume. When you divide the mass by the volume, you arrive at the density of 9 and 3700 grams per centimeter cubed. That's pretty close, says your teacher. But now you need to calculate your percent error. The correct value for the density of this metal is 8 and 9200 grams per centimeter cubed. Okay, so to calculate percent error calculations, you determine how accurate or how close you are to the true value of an experimental value. So to calculate the percent error, you would take the difference, you would subtract the experimental value and the true value, divide it by the true value, and then multiply it by 100% to get a percent. A low percent error means that the result you obtained was very accurate. A high percent error means that your result was not very accurate. You may have made your measurements carefully enough, or your measurement tools may have been of poor quality. So you're going to have to do these sample ones in your homework. So let's look at this. You calculate the density of an object to be 9 37/100 grams per centimeter cubed. The density of the object is actually 8 92/100 grams per centimeter cubed. So what you're going to do is take 9 37/100 grams per centimeter cubed, subtract 8 92/100 grams per centimeter cubed, and then you can take that number and divide it by 8 92/100 grams per centimeter cubed. Take that number and multiply it by 100, and you get 5.04% is your percent error. You will need to do math questions 1 and 2 as part of your homework. Mean, median, and mode. Walking along a beach one summer night, you spot a green sea turtle. The turtle has laid its eggs in the warm sand. How many eggs does a green sea turtle lay? Suppose you count the eggs and find that there are 107. Do all green sea turtles lay 107 eggs? To find out, you would have to study many more turtle nests. Figure 14 shows data from a survey of green sea turtle nests on the beach. Notice that the number of eggs ranged from 94 to 110. How can you use this data to find the average number of eggs? There are several ways to determine an average. They include mean, median, and mode. Mean. One type of average is called the mean, or numerical value. Is calculated by adding all the numbers and then dividing by the total number on the list. You've done this in math class a lot of times. Median. Sometimes it may be more useful to know the median or the middle number in a set of data. To find the median, place all the numbers in order from smallest to largest. If the order list has an odd number of entries, the median is the middle entry in the list. If it has an even number of entries, you find the median by adding the two middle numbers together and dividing by 2. Mode. A third way to represent an average is called a mode. The mode is the number that appears most often in a list of numbers. The mode is particularly useful when a list contains many numbers that are the same. Okay? Your homework is to do section 2 assessment plus math practice from the reading and also these 2 math practices here. I will also upload a video from YouTube about adding, subtracting, multiplying, and dividing significant digits. All right, I will see you tomorrow. Bye.